hopefully you have seen my error here. And it's just an error of signs. And what we have is, of course, we have a negative times a negative to give us 6 meters per second. But there's also a negative out in front here, which I applied to this term, but did not apply to this term. So that should have been minus 6 meters per second. So we're going to have a negative 10 meter per second here. And also here. And here. And here, and as I said, this had to be a negative change because obviously this thing's at least going to slow down, perhaps we can reverse direction. Okay, so 3/5 of negative 10 meters per second is negative 6 meters per second, added to 4 meters per second, both times I, gives us negative 2 meters per second. Times I. So we see that the velocity of the second ball after collision is going to be negative 2 meters per second times I. And now we can write that as our solution. That is our U1, and this is U1. So U1 is negative 2 meters per second times I. Now there's a little more we can do with this because one thing that turns out can't happen is the total kinetic energy of these balls without some external application of force has to be less than it was or equal to what it was before the collision. So let's just work that out. So okay, so what we had was V1 was 4 meters per second. M1 was 5 kilograms. V2 was negative 6 meters per second. And that's times I. And M2 equals 3 kilograms. So before collision, total kinetic energy is 1/2 of 5 kilograms times 4 meters per second, quantity squared, plus 1/2 of 3 kilograms times negative 6 meters per second, quantity squared. And this comes out, what, 16? Half of that is 8 times 5 is 40. And 36 here, half of that is 18 times 3 is 54. It's 94 kilogram meters squared per second squared, which is 94 newtons times meters, which is 94 joules. After collision, we got U1 equals negative 2 meters per second times I. U2 equals 4 meters per second times I. So what's the kinetic energy? Well, without writing out all of the details, we square this, we get 4. Half of that is 2, we get 10 kilogram meter squared per second squared for the kinetic energy of the first ball. And for the kinetic energy of the second ball, squaring this is 16, half of that's 8. Multiplying that by 3 kilograms, you get 24 joules. So just to write down both, we get 10 joules plus 24 joules equals 34 joules. Okay? Total kinetic energy after is less than the total kinetic energy before. So what happened to that energy? Well, most likely it was dissipated, turned into the energy of the sound of the collision, thermal energy of the compression, and perhaps even there were some external forces involved. Again, the total kinetic energy after can't exceed the total energy before, but it can certainly be less.